So let's just see where this leads. Okay, so you have this matrix, we want to find eigenvalues, so we form the this matrix, okay, which is your A minus lambda I matrix. I'm assuming everybody understands all that. Okay? So the determinant is what?
3 minus lambda times negative lambda times negative lambda.
Right? And it's minus 2 times the determinant. Well, you got a couple of zeros in here, right? And same thing's going to happen with this one. So these are both zero. They have columns of zeros, right? So you're just left with, okay, well, the equation becomes this equals 0. Then we have 3 minus lambda times what? We're going to have lambda squared minus 4. So your solutions, lambda is going to be 2, negative 2, or 3.
And we found that it worked with 2 and negative 2, but not with 3.
Okay, well, it might be the fact that's a perfect square. Let's see what happens. Okay? So what we get then is this should be the 0 matrix. No, it should be 0. Okay? So if lambda equals, well, you say it doesn't work for lambda equals 3. Well, let's do lambda equals 2 just to, and then I'll take your word for a negative 2, right?
Yeah.
So what you get is you get 3 minus 2, 2, 1, 0, minus 2, being careful, 2, 0, 2, minus 2, right? Okay? And then that would be like that times an x1, x2, x3 equals 0, 0, 0, right? Something about that. Wants to disturb me, but doesn't really. Okay, so anyhow, from this equation, we get x2 equals x3, right? So that this is just going to give you x1 plus 2x2 plus x3, right? Then, sorry, x1 okay? And x2 equals x3, so x1 has to equal negative 3x3, right? And tell me if you don't follow any of this, I'm doing it kind of quickly.
Okay.
But you've worked on it. So you let x3 equal t, so we're going to have t, negative 3t, right? Which equals t times negative 3, 1, 1. So negative 3, 1, 1 should be an eigenvector with eigenvalue 2. Okay? So if we multiply this matrix by 3, 1, 1, we should get negative 3, 1, 1. We should get negative 6, 2, 2. Now you follow all that? Okay, I'm doing it kind of quickly just to set us up for whatever happens when lambda equals 3. Okay? Then, okay, multiply this. 3, 2, 1 times that is going to give me negative 9 plus 2 plus 1, which is negative 6. Now 0, 0, 2 times that is going to give me 2. And 0, 2, 0 is going to give me 2, so it verifies. So that's your general eigenvector for lambda equals 2, and of course any multiple of that. Okay? Okay, so let's see what happens if lambda equals 3. Okay, I'm just going to write down the augmented matrix that we get. Because of course we're saying this times this equals 0, 0, 0. That's equivalent to just reducing the augmented matrix with a bunch of zeros in it, right? So we get 3 minus 3, 2, 1, 0, and negative lambda, negative 3, just try to be careful, 2, okay? And 0, 2, negative 3, right? And of course we get our column of zeros. And what we're really doing, of course, we're just okay. And look, I see where we seem to get a contradiction, so let's see what we can do about that. We got 0, 2, 1, right? And 0, negative 3, 2, and 0, 2, negative 3. One of those should be a multiple of the other. But, and, because I've forgotten again. Okay. So we could make that and I'm going to take a chance subtracting 3 times this, or adding 3 times this to this would give me a 0 here, right? And adding 3 times this to this would give me 7 halves. And adding negative 2 times this to this, try to be careful and get it right, okay? I'm going to get a 0, and negative 2 times this is negative 1, right? And negative 1 added to negative 3 gives me negative 4. Okay? And that reduces down to 0, 1, 0, 0, 0, 0, 0, 0, 1. Telling me that x2 has to be 0 and x3 has to be 0 doesn't tell me anything about x1. So x1 could be anything. Which means that the vector 1, 0, 0 is an eigenvector with eigenvalue 3. And you can see that that happens. Okay, if we multiply the matrix by that, we get 3, 0, 0. Okay? So it might have been the fact that you didn't have anything here, whatever way you did it. You could have written out the simultaneous equation. You didn't get anything that restricted x1, but you saw that x2 and x3 had to be 0. Okay? So, whether you did it by this method or any other method like what I did here, it's all equivalent. And we get so your eigenvector is this. Okay? And we verified. So I really think the only thing that threw you off was just the fact that you didn't have anything for x1, which means x1 can be your parameter. Okay?